Now here in the first example, now this is the second example. In first example, there is a rod and the mass is attached at the end of this rod. Okay, and you have to find out the frequency of the given system. Now in second example, you have to attach only the spring here. Horizontally, the spring is attached here. Okay, at the distance A from the pivoting point. Yeah, the distance given here, and the length of the mass is, oh sorry, length of the rod is given here L, mass of weight by M. Okay, now stiffness of spring is K. Okay, now you have to find out the frequency of the given system by using the equilibrium method and energy method. Okay, now you have to first of all solve this problem by using the equilibrium method of the D'Alembert's principle. Okay, now in that D'Alembert's principle, what is the equation of D'Alembert's principle? Anyone? Equation A? Equation of D'Alembert's principle. What is the equation, Aditya? Summation of inertia force plus external force is equal to 0. Correct? Okay. This in this equilibrium method, you have to write down the inertia force or inertia torque, you can say, because there is a angular moment. Inertia torque plus external torque is equal to 0. Okay, now I have to displace this system from its equilibrium position. That's here. The equilibrium position. I have to displace this mass at an angle theta. This angle is theta. Okay, now when the mass is displaced at an angle theta, now the spring is staged. Correct? Now the spring gets extend at a distance x. Now this is the x distance. This much distance gets spring get extend or x1. Okay. Now you have to find out here the natural frequency of given system by using the equilibrium method. Now this distance is given A, total length is given here L. Okay, now you have to find out the various forces acting on this system. But tell me, what are the different forces acting on this system? Here is the mass act downward direction. Resolve this mass into two components. Now this is your mg cos theta, similar to the previous example. Mg cos theta, your mg sin. Okay. Mg sin. Okay. Now when it is displaced, now this mass is displaced in this direction. Okay, at an angle theta means inertia force act in opposite direction of this direction. Now, what is the magnitude of inertia force? What is the magnitude of inertia force or the inertia torque? क्या रहेगा magnitude? Abhay, what is the magnitude? Rishikesh, am I audible or yes or no?
Yes, sir.
क्या magnitude रहेगा inertia torque? Anticlockwise direction. Its magnitude is I. Mass moment of inertia of this rod about the O. Now you have to see, write down here the O point. I alpha. Correct. Instead of alpha angular acceleration, you have to write down the theta double. Theta dot. Theta double dot. Okay, acceleration. Now this is the inertia torque act on the body. There will be one more force act on this system is due to the spring is your spring force whose magnitude is kx. Correct? X. But from figure, anyone tell me what is the magnitude of x? X is equal to क्या होना चाहिए? This is the distance x. It is arc. Okay, now tell me the distance x. Arc कैसे निकालेंगे? Radius into theta. Angle. Radius क्या है? यहाँ पे distance is a. Now this distance is your a into theta. This is the distance x of the displacement of spring X is equal to A theta. Okay, now there are three forces acting on the system. First is the inertia force, then spring force, okay, or the inertia torque, then torque due to the spring force. You have to find out the torque due to the spring force is your kx into जो भी distance रहेगा. Now it is a distance, kx into a. Okay, and next torque due to the mass, component of mass, mg sin theta into L. mg sin theta into L. You have to put this value into the equation of equilibrium method. Inertia torque you have to have here. Write down here I O theta double dot plus external torque due to the spring force is your kx into distance. How much is the distance? Distance कितना है? Kx into the spring force act at a distance. L or x? Mohammed? Yeah. Here the spring force act here. Now tell me the torque due to the spring force. Kx into distance क्या लेना है? L लेना है या A लेना है? Hello. Cool. Park. Now the screen is visible to all. Say something. Yes. No.
Yes, sir.
फिर डिस्टेंस क्या आने वाला है यहाँ पे आदित्य राज? Kx into distance is spring force act here. Torque due to the spring force is your force into distance. Force क्या कहाँ पे act हो रहा है? At this point. उसका distance कितना है? A ना? Is it visible? A. Kx into A. The next force or the torque due to the component of mg sin theta plus mg sin theta into mg sin theta into distance. What is the distance? Mg sin theta into what is the distance? Hello, Parth.
L.
L. Okay, is equal to 0. So now this is the equation. I have to simplify this equation. You have to put the value of x here. Okay, now x is equal to what? A into theta. Theta double dot plus a x is equal to a theta means a into a square theta plus mg sin theta is equal to theta. You have to consider here mg L theta is equal to, okay, or you have to take down here theta common. यहाँ पे theta common लेना है. Then you have to divide it by this IO. This you will get the next step is your final step. I theta double dot plus into bracket a square plus mgl bracket complete theta divided by IO. Mass moment of inertia of this rod is equal to 0. Okay. Now we know the equation of simple harmonic motion. What is the equation of simple harmonic motion? Theta double dot plus omega n
Omega square x.
correct. Omega n square theta is equal to 0. Now you have to compare it with this equation. You will get here omega n square is equal. Omega n square is equal to, you will get here a square plus mgl
Upon I0.
I. Or you have to write down omega n and you have to find out the frequency. You know the formula of frequency. Fn is equal to omega n upon 2 pi.
2 pi.
Correct. is equal to 1 upon 2 pi under root of k square plus mgl
upon ml
divided by
square.
f. Huh? I. Okay, now this is the equation of frequency of the given system by using the equilibrium method. Okay. Now in this problem, when you have to solve this problem, the hard task is your to find out the various forces acting on the system. Because you have to displace this system at an angle theta yourself. Then you have to see the various forces and the couple act on this system. Okay. I have to write down this. Okay, now see this is the displaced diagram. Consider the system is displaced through an angle theta, due to which the spring is stretched by a distance x. Okay, now this x distance is your curve. ये वाला कर्व कैसे निकलते हैं, आर्क का डिस्टेंस कैसे निकलते हैं, रेडियस इनटू एंगल. रेडियस कितना है यहाँ पे, एंगल ए एंड एंगल थीटा मींस ए थीटा. x is equal to a theta means spring force क्या आएगा यहाँ पे, spring force act in this direction. Its magnitude is equal to F is equal to kx. Instead of x, you have to write down a theta. Okay, now all of you draw this figure and write down the x is equal to a theta. Do it fast. All of you draw this figure. Do it fast. Okay, हो गया रजत? Okay, now there is no need to draw this figure. Okay, only you have to draw this figure. Already you have done. Okay, now you have to write down the equation of equilibrium method or D'Alembert's principle. Summation of inertial torque plus external torque is equal to 0. And the given figure inertial torque is your in the same figure you have to show the inertial torque. I will theta double. Okay, and this is the spring force X. Okay, now the torque due to the inertia torque you have to consider, then torque due to the spring force you have to consider, and torque due to this mg sin theta you have to consider. And you have to write down the equation. I O theta double dot plus mg sin theta into distance L, total distance you have to consider here, plus kx into distance A. Now this distance is your A. So now you have to simplify this equation. Instead of x, you have to write down instead of x, you have to write down here a theta, and sin theta is equal to theta. Okay, you will get the next equation, I O theta double dot plus mgl theta plus k square theta is equal to 0. Then you have to take down the theta common. We go to the next step. I theta double dot plus into bracket mgl plus ka square into theta is equal to 0. All you have to divide it by this throughout the equation IO. You will get the final equation theta double dot plus mgl plus k square upon IO theta is equal to 0. Okay, now for this you have to write down. This is the equation of motion to find out the frequency of given system. I have to compare this equation with the equation of simple harmonic motion. Shashwat, is there any doubt?
No, actually not, but just keep this on for a bit.
All of you note down this equation. चेतन हो गया? आयुष? Okay, now we have to compare this equation with the equation of simple harmonic motion. We know the equation of simple harmonic motion is equal theta double dot plus omega n square theta is equal to 0. Means omega n square is equal to mgl plus k square upon I, or omega n is equal to under root of mgl plus k square upon I. Now we know the frequency of vibration is equal omega n upon 2 pi. Instead of omega n, you have to write down the formula. Okay, you'll get the frequency 1 upon 2 pi under root of mgl plus k square upon I hertz, or put the value of I is your L square, mass moment of inertia of this system with respect to O. Okay, you can finish up to this. Okay, done. अब भाई हो गया?
Yes, sir.
Have to solve the same problem by using energy method. Okay, now energy method is here. I will draw the figure again. This is the equilibrium position. Now here is the spring. Okay, now draw your spring. Now the system is displaced at an angle theta. Now this is the distance x. Now this distance is a. Total distance is L. 500.0. Okay. Now in energy method, you have to find out the kinetic energy and potential energy, and you have to differentiate it. Okay. Now first of all, we will see the kinetic energy of mass. Or the formula of kinetic energy of mass, anyone? Kinetic energy of mass क्या आएगा? What the formula? 1/2
M into x dot square.
m into x dot square. X dot square. Now you have to see here from the figure, you have to write down x is equal to, what is the x is equal to? X is equal to a into theta, because x is arc, a theta. X is equal to a theta means x dot is equal to a theta dot. A theta dot. Means you have to put this into this equation. You will get here 1/2 m a square theta dot square. A square into theta dot square. This is the kinetic energy of mass. Now next, potential energy of mass. Because the mass is lifted up at a distance h, you have to consider the potential energy of mass. क्या निकाल कैसे क्या है फॉर्मूला इसका? Potential energy of mass is equal to mgh. Correct? Now it is similar to the previous example. Now find out the h here. H क्या है यहाँ पे? Now this is the distance h. H. How can you find out this h? Again same as previous. Okay. Now this distance, we know this distance. ये कितना आएगा distance? Now this is the right angle triangle. Now this side is your adjacent side. It's cos theta means L cos theta. Okay. Means a distance क्या आएगा? Total length is your L minus L cos theta. Means h is equal to your h distance or height or lift of the mass is equal to h is equal to L minus L cos theta. Okay. I have to put this value of h here. Means you will get here m g L minus L cos theta into bracket L minus L cos theta. Okay, now one more potential energy you have to find out here. Which one? कौन सा रहेगा potential energy? Potential energy of spring. Potential energy of spring. The potential energy of spring is equal to, what is the formula? Anyone? 1/2? 1/2
Kx square.
Kx square. Again, you have to put the magnitude of x here, a theta. You will get 1/2 into k a square theta. Once you will get the energy, you have to put the value into the equation of energy, total energy, or you have to differentiate the total energy, kinetic energy plus potential energy. Equal to 0. Now you have to put this value here of the equation, d upon dt. Bracket kinetic energy is equal to 1/2 m a square theta dot square plus next is your mg. I'll directly write here multiplying by this mg to the bracket mgl minus mgl cos theta. Okay, and then next is plus potential energy of spring 1/2 k a square k a square theta equal to 0. Okay, now you have to bracket complete here. Now you have to differentiate it. First term you have to differentiate first 1/2. Next is your m a square. Differentiate theta dot square. क्या आएगा 2 into theta double dot theta dot. Now MGL is 0. Next, minus cos theta means you will get here plus MGL sin theta plus last term you have to differentiate here spring का 1/2 Ka square to theta dot theta is equal to 0. Okay, how do you understand this equation? All of you? Hello? Yes or no?
Yes, sir.
Now next, you have to cancel the terms. Now this 2 to get cancelled. Okay. Now that case 2 to get cancelled. Now one term is remaining here. See here when we differentiate this mg cos mgl is the L sin theta theta dot. Here is the theta. Here is the theta. Okay. Now to cancel again theta dot. What term is remaining here? This is the theta. Again sin theta is equal to theta. You have to consider. I'll write the next equation is your m a square theta double dot plus mgl sin theta is equal to theta plus ka square theta. Again, this is a constant. Now, one of the term is wrong here. Here, when you take the kinetic energy of mass, this one. Okay, now this is your linear kinetic energy, mx double dot square. Now, but the displacement of the mass is angular. Means क्या लेना चाहिए यहाँ पे 1/2 1/2. Hello. If there is angular movement, then kinetic energy of that mass is 1/2 I O theta dot square. Is it right? Hello. See here, this term. Again, this term get cancelled here. क्या आएगा 1/2 kinetic energy of mass when there is angular moment I/O theta dot square. Okay. Next, you have to put this 1/2 I/O theta dot square. Means यहाँ पे क्या आएगा 1/2 I/O 2 theta double dot theta dot means to get cancel here means you will get here theta double dot plus mgl और यहाँ पे I/O theta double dot plus mgl theta plus k square theta is equal to 0. Or you have to write down theta double dot plus into bracket mgl plus k square divided by I/O. Bracket complete, theta is equal to 0. This is the equation of motion. You will get the same as the equilibrium method. Okay. Now see here, kinetic energy of mass for linear and angular. There is a difference. For linear, you have to take down the 1/2 kx square instead of mx square, mx dot square. Okay, 1/2 mx dot square or mv square. Okay, but for angular moment, you have to take down 1/2 I alpha. I alpha means I theta dot square. Okay, you have to solve this by using this energy method. Again, you have to compare this equation with the equation of simple harmonic motion. You will get the omega n and you have to find out the frequency. Got it? Now see the original equation I will show you here. Kinetic energy of mass is equal to 1 upon 2 I theta dot square. Potential energy of mass mgh. You can say mgl bracket 1 minus cos theta, or you can write on mg into bracket l minus l cos theta. Then potential energy of spring 1 upon 2 kx square. Again x is equal to a theta. Okay, according to energy method, you have to write down the equation d upon dt total kinetic energy plus potential energy, and you have to differentiate it. You will get this equation. Okay, everyone write down this equation. Figure for this, you have to try draw this figure. To the h. Okay, find out the distance. The distance equal to L cos theta. h कितना आएगा तुम्हारा? h is equal to L minus L cos theta. Okay, now draw this figure and you have to write down the equation. Okay, done. Fish. Ethan. Okay, सबका? Hello. Okay, done all of you? Yes or no? Hello.
Yes, sir.
Now take down the next one. Now the figure is given here. Now this is the figure for this problem. Either you have to solve the numerical by using the energy method or equilibrium method. Okay. Now you have to continue this problem. You have to compare the above equation with the equation of simple harmonic motion. You will get the same equation as the equilibrium method. Hello. Okay, done. We'll take the next one. We'll take the next. Take on this numerical. What? Spring is attached. I should be here. There is a torsional spring. Again, is given here L. Okay. Now, stiffness of the torsional spring is your KT, and this spring is your K. Okay, now you have to find out either by using the equilibrium method or energy method. You have to find out the frequency of the given system. Is it visible? Yes or no? Now you have to displace the system from the equilibrium position. Here, so we will displace the system from the equilibrium position. This is the equilibrium position, you can say. Of the torsional spring A. The displacer from its equilibrium position like this. Okay. Now the spring is stretched at the distance x. Now this distance is your x. This distance is your L. Find out turn by this your theta. Now you have to find out the equilibrium method, find out the frequency. Now tell me various forces acting on the system. What are the forces acting on the system? Now spring force acting in this direction. Its magnitude is your kx. Okay. Now inertia force or inertia torque act in the opposite direction of rotation, means anti-clockwise. Its magnitude is I O theta double dot. Okay, and one more torque, restoring torque act in this direction. Okay, is torsional spring है यहाँ पे ध्यान रखना. Its magnitude is your KT theta. Its magnitude is your KT theta. Now see the various forces acting on the system. Now here is the torsional spring is used. Means you have to consider here the torsional force or the torsional or the torque because of this torsional spring KT theta. Or you can say it is a restoring torque. Okay, अगर यहाँ पे spring हमने पकड़ा ही नहीं. Now if you do not consider the spring K, stiffness K, now it get this system get come to the equilibrium position because of this torsional stiffness KT. Okay, you can say it is a restoring torque. And inertia torque also act in the direction towards the equilibrium position I O theta double dot and kx. Now, according to equilibrium method, you have to write down the equation. What is the equation? Inertia torque plus external torque is equal to 0. Now, inertia torque is your I O theta double dot plus restoring torque is your kt theta plus torque due to the spring force kx. ऐसे निकालेंगे force into distance kx into L. L is the distance is equal to 0. But if you see the figure, x is equal to what is the x? Anyone tell me what the distance x? How can find out this x? Again, it is arc. क्या का distance? X is equal to hello. Distance x is equal to क्या आएगा? आयुष कैसे निकालेंगे? X is arc. Arc कैसे निकालते हैं? Radius into
L
theta.
into theta.
L into theta. Now I have to put this L into theta in this equation. You will get the IO theta double dot plus kt theta plus k into x. X is equal to L theta. L square theta. Again, final equation you will get here theta double dot. In terms of theta double dot, you have to write on the equation. It's divided by IO. kt, you have to take down here theta common plus kl square bracket theta divided by IO equal to 0. Is it right? This is your D'Alembert's principle. Again, you have to write down the simple harmonic motion equation. Okay, or equation of SHM. You have to complete this problem. Equation of SHM is your theta double dot plus omega n square theta is equal to 0. Hence you will get here omega n square is equal to circular natural frequency of the given system is equal to kt Gaussian thickness plus kl square on IO. Or you have to write down directly frequency Fn is equal to 1 upon 2 pi, means omega n upon 2 pi. Instead of omega n, you have to write down the under root of omega n square is equal kt plus kl square upon IO, means under root of kt plus kl square divided by IO. This is using the equilibrium method. Now energy method में क्या आएगा? Kinetic energy क्या आएगा यहाँ पे? Anyone tell me kinetic energy of rod? Kinetic energy of rod is equal to kinetic energy of rod क्या आएगा? 1 upon 2 I O theta dot square. Next, potential energy of spring, or you can say torsional spring. I'll write here T spring. क्या आएगा यहाँ पे? पोटेंशियल एनर्जी कैसे निकलते हैं? 1/2 kT x square. Okay. Next, you have to write down the potential energy of spring. क्या आएगा? 1/2 kx square. Now here you will get 1/2 k theta square. You will get here 1/2 k theta square. Okay. now यहाँ पे kx square. Now kx means you have to, instead of x you have to write down a square, sorry, L square theta square. Okay, I have to differentiate this a upon dt. Kinetic energy of rod is equal 1 upon 2 IO theta dot square plus 1 upon 2 kt theta square plus 1 upon 2 kl square theta square. Okay, और डिफरेंशिएट किया तो क्या आएगा यहाँ पे 1 upon 2 IO 2 theta double dot theta dot plus 1 upon 2 kt into 2 theta theta dot, and I will write here below plus 1 upon 2 kl square theta theta dot is equal to 0. Again you have to cancel the similar terms. So यहाँ पे 2 get cancel, 2 get cancel, 2 get cancel. Again यहाँ पे 2 रहेगा because it is a theta square. 2 get cancel, again theta dot get cancel here. Okay, now theta you have to take down common, means you will get here I O theta double dot plus kt plus kl square, bracket complete, into theta. Okay, you will get the same equation as this one. Okay, or you have to take down I here below. You will get the same equation as the equilibrium method. Okay. Hello everyone. Are you understand or not? अरे समझ में आ रहा है कि नहीं? धनश्री, कल्पेश,
Yes, sir.
चेतन, समझ में है ना both methods? Okay. Now suppose here I will change here the problem. Suppose we add here one more spring. Okay. क्या हो जाएगा यहाँ पे? This spring get compressed at the distance x. Again same. Spring force भी same आएगा यहाँ पे kx. Okay, means kx case you will get the two. Means potential energy of the two springs you have to consider. Same यहाँ पे क्या आएगा? kxl. और this one also you have to add here plus kxl. यहाँ पे change हो जाएगा. See this equation because you have to solve this problem for your homework. Now यहाँ पे change हो जाएगा. यहाँ पे change क्या होगा? 1 upon 2 into 2 because there are two springs. Now 2 get cancelled. Means this get cancelled. You will get here kx square. Potential energy of two spring is equal to kx square. Okay. Instead of this one, you have to write down kx square. You have to take down the screenshot of this and you have to solve this problem for your homework. समझ में है क्या करना है यहाँ पे? हेलो, इज देयर एनी डाउट? ओमकार, अजिंक्य, हेलो एवरीवन.
नो सर.
क्या डाउट है का?
नहीं सर.
आदित्य, समझ में है ना?
Yes, sir.
We consider here one spring and we solve the problem. You will get the answer is your frequency A वाला आ जाएगा. Fn is equal to 1 upon 2 pi under root of kt plus kl square upon IO. But if you consider one more spring here, both are in, one is attached above this rod and below rod. Means अगर मैंने इसको नीचे displacement किया, upper spring get expand x distance and lower spring get compressed x distance. Means distance is same. Again, upper spring pull the rod upward direction and this lower spring push the rod in upward direction. Means both act in upward direction. Okay. तो क्या करना है यहाँ पे equilibrium method में you have to add the KXL plus KXL. Okay, now the moment of the torque due to the one spring and another spring, you will get here. Same you have to potential energy of two spring, you will get here kx square, and you have to solve it. Okay. Take down the screenshot of this. All of it. Okay, I will. Today I will not take attendance because all these are present here. Here, 42 students are present. Okay, now see, these are the present students. Okay, now we can leave the meeting. Tomorrow we'll see the numericals.